So today I'm going to go through some fundamental tips and tricks. Most of you are supervisor users already, so I'll just be covering some fundamentals. That won't be earth-shattering to some of you, but for our newer users, hopefully you'll pick up a lot more tips and tricks that will increase your efficiencies with using these tools. So to start off, I'm going to talk about loading data and the grouping powers of Supervisor. So where Supervisor really has great power is to analyze multiple group domains as you guys see fit. So where this happens, obviously on the right-hand side of our grouping, we've got the ability to load things by domain and assay. That's all dependent on the mapping type. So you can do things like assay over domain, or if your data just has assay or domain, that's where you define that as well. In terms of loading multiple domains, where you put that order is down the bottom here in the grouping column. So that will just specify what domains you're actually loading by. So in this scenario, you can see I've got a numeric domain being my all load of 100, as well as the multi-element assay data being gold and silver. And I've loaded my third domain being the drill hole type to investigate our first pass EDA to see if I've got any biases between my drilling types in my areas. So obviously I've just showcased 2 domains, but we can go further. So you just add more and more domains as your data set sees fit. So another thing that is a real time saver, particularly when you're working on the same kind of deposits or you're doing the same day-to-day tasks, is actually taking time out to set your defaults. So here I'm just going to play a little video where I'm currently working on a gold project. I'm wanting to do my variography analysis. So I'm starting off by putting in my default horizontal, across strike and dip plane bands, as well as the continuity model. So obviously in gold, working in positively skewed data sets, we want to really be looking at a bit more detail. The defaults are set to a number arrays of 18, and we're not transformed at all throughout all of those things. So what we really want to do with our positively skewed data is move it into the normal score space. So where we go to do this is in our systems tree. So you just click down the bottom, pick on your continuity analysis. I type in the default of 36 because I like seeing 5 degrees, and put on my normal scores transform. Here is where in that properties panel you can change other default settings as well. So if you do need to drop your minimum pair count, we obviously leave it generally as the recommended 30. Or if you want to add extra spherical structures, you can do that as well in here. And we'll have a look while we're here, and we will put in our default for our continuity model as well. So now I'm in gold space working on gold projects. I've set up my defaults for the variography. Again, if you want to add a third spherical structure, we can. And now I'll just delete the original default and add in my variography analysis. And you can see now we're automatically got 36 sprays populate, and we're in the normal scores space without even having to do anything. So small time saver, but when every 5 minutes counts at resource time, it's great to know that you are working in the areas that you need to be. Great. So obviously setting defaults as well can be applied to other facets, so everything in Supervisor, you can set those defaults for. So next screen, has anyone had the pleasure of opening a project they're unfamiliar with and seeing all these warnings in Supervisor? I definitely have. So what does all that mean? Well, this is where potentially our link to source and knowing how Supervisor works in the project settings really comes in to be important. So obviously there's a few bits and pieces that can have this happen. So to start with, if we look at our actual data nodes here, so our estimate AU, we can see we've got a warning there. So generally we check that, and if it was currently as a live link to source, what it might mean is it needs an update. So if we've got access to those files and we click on that, it will automatically update and that warning will go away. However, if a project has been moved from a user's C drive onto a server and you've just opened it, you won't have access necessarily to those files in that file path and they need to be relinked. So that's the first check that you can do on those data nodes to make sure that you actually have access to all that information. The second warning we can see is up at our Variography, our continuity fan analysis. And what that warning generally will represent is that the actual analysis process needs to be updated or rerun. So there may be a couple of reasons for this, but generally it might be that you're missing the bin files, which holds all the process data in there. So basically, what do we do? Do we choose live, warning, or detached to our link to source? So obviously there's certain times where these are preferable, but linking live is great to do when you're doing your model updates and running and rerunning different scenarios to ensure that you are using your most up-to-date data. So the link to source with a warning is quite similar in the fact that you'll get a warning when you rerun those files, but just because you click on a node doesn't mean it will automatically update. You might actually have to press, or you will have to actually press the update button to make sure it updates. So moving to detached projects. So the advantage of detaching a project, particularly at the end, is making sure that all the data is held inside your project. So in this case, you can see I've potentially finished my project. I want to send it off for peer review. I've detached my files, which you can see in the project tree because it now has brackets appeared around it. So that's a good sign that your project has been detached successfully or your files have been detached. So it is great because you can also then send this off to a supervisor or a senior for easy review. They're not going to have to relink anything at all, so it saves them time as well. So generally, we recommend keeping both the .spv8 project files and the bin results together. It's the best way for data storage to make sure that you are able to keep all these files in place. And as a bare minimum, if you do just keep the project file, you will have all the data and it will be sufficient, but you just have to keep in mind without the bin files, you will have to reprocess any analysis completed. So if you've done something like conditional simulation in that space, it's just going to take you a bit of time to rerun that. So that's just a little picture of your project files with the icon versus your bin results with the folder. So that's what we mean by that. So reporting, this is obviously a massive part of our job, reporting and documentation. So generally can be quite a tedious process. A lot of time is saved in Supervisor by having the ability to copy straight from Supervisor. So we've just got a little copy button on our sidebar, and we can paste that directly into Excel or Word or whatever documentation type you're using. You can also alternatively just use the visualization window, and you can actually set a format to copy these to a certain number of graphs per page, or you can actually print to PDF and specify these as well. So where this is really good, obviously, is if you've got a whole heap of EDA that you want to export out as a PDF for an appendix, it can definitely be a time saver on that one. All right, so moving on to our contact analysis tool. This one is getting more popular, definitely, but it is great to be able to give some kind of geostatistical evidence as to why you've chosen a specific boundary type in your resource estimation. So I'm just going to run through a quick video. In this scenario, we're actually looking at a boundary over a weathering program. So here we are loading a data set where we've got an iron oxide assay, and it's been domained into an oxidized and in situ domain. So they've just been given 0 and 1 as a numeric. So we just right click on our input data and add in our contact analysis. We process that, and then we just need to make sure that our maximum distance and number of bins is equal to the sample length of our data. And you can see we've come up with a great little summary plot at our contact, and as we move away, looking at those statistics. So you can see we've automatically got some stats up the top right, and Supervisor does try to automatically put a boundary classification. These are based on some massive geostats rules, which can be found in our help menu from this paper. So we've had to apply, obviously, these hard and fast rules, but at the end of the day, we need to relate that back to geology. It's currently saying that there's no boundary here, but I think most of us would agree that we would apply a hard boundary in this scenario. So please make sure that it does make sense geologically, and it's just something to be mindful of. Okay, so here we are moving on to some top cuts and top caps. Oh, we've started playing. So there's a couple of ways to apply your top cuts and top caps. So I didn't mean to before. Oh, I've gone way too far. Sorry, I've skipped a slide. All right. No, again. It's the first time I've embedded videos into a presentation. Okay, here we go. So if you apologies for that, guys. All right. So over in the right, we can see our max values in the property window. And if we do want to apply the top cut or a top cap, we do it through here. And then it is adjusted in our data set, which you can see. So we've just applied a percentile, but if I want to do a top cap, I'll use the @ symbol instead. And you can see now I've got 13 samples being cut in my data set. So again, we can export all these stats out if we like, and you can see now I've got a full statistics as well as the number of samples that are going to be cut in my data set. So we can either obviously type in values, or we can also automatically put a percentile in if we do use our percentage button. All right. So one of our newer tools that is gaining popularity for particularly our high nuggety deposits is our global top cut analysis tool. So here in our input data, we just right click and add our global top cut analysis, and 4 graphs of our histogram, log probability plot, mean and variance plots, and cumulative metal automatically populate. They're all linked together. You can unlink them and investigate them separately, but you can see quite interactively as you move through the graphs, the impact where the top cuts will be applied. You can also insert a hard value just by typing it in, and it will automatically update. You obviously have your stats moving interactively, so you're able to see straight away the impact of your raw and top cut, which once you're happy with that, you can also export that out to a CSV. So all your summary statistics with metal cuts summarized, your number of samples, and what percentile that's been cut to. So quite handy to see that all interactively. All right, so moving on to our big ticket item in Supervisor, which is obviously our variography. So it definitely has a easier workflow than many other products. So something that's known as the black art of resource geology generally will become a breeze in Supervisor. So I'm just going to take you through a 5-minute video. So here we're obviously defining our rotation angles, and Supervisor actually uses a 3-fan stepped approach to do this. So to start off with, we're looking at our horizontal continuity fan, and this is the equivalent of our strike. We can easily move through our drill spacing lags and see both our fan as well as the variograms modelled on the right-hand side. You can see Supervisor's automatically auto-fitting those variograms as well. And what I really love about it is being able to use the 3D viewer window to see your modelled rotation angles in relation to your spatial data. So once you're happy with your strike, you can then move on obviously to your across strike plane, which we're looking at the dip geologically here. So we've got our blue and our red pointers, red pink, which we can obviously see the graphs being highlighted, and we can also see that being modelled in our 3D window. So if we're looking at comparisons between orientations, we can see what fits best with our data. So the final step is to do our dip plane, which, dependent on whether or not your ore body has a plunge, you can apply that one there. So again, very easy to move through the lags, to zoom into your spacing, and we're obviously looking at our low continuity to higher continuity from blue to red as well in those fans. So once we're happy with all of our rotation angles being defined in our 3D space, we can then move on to the second part of the process with our variograms, which is the continuity modelling. So that's easy as a right click and adding the continuity model. You can see that Supervisor will automatically try and auto fit, and we do stress that this is a starting point. So In some data sets, it can do a really good job, but we always recommend making sure you guys review that yourselves. So I really like this view with all 4 variograms being shown at once. We obviously have our downhole variogram first, which looks all right in this case, so we've left it alone, and we're going to move straight on to direction 1. So obviously we can fit those structures as we see fit. And what I like about all the views being shown together is you can see the impact that moving your structures in your different directions has on direction 2 and 3 and vice versa. So I find it a very useful tool for teaching people visually the impacts of moving these structures around. We also have a really cool copy and paste function that you can basically move between your directions. So once you're happy with direction 1, you can move it to direction 2 and then rejig it. So at the moment, we're just going through and looking at the lock sills function and lock ranges as well, which basically means once you're happy with a direction and you want a bit more control, you can either lock the sill or the range for a bit more control. So once we've been happy with our direction 2 modelling, we can then do the copy and paste as well to ensure that we aren't modelling any overlaps in our variogram. And then we can have a look at our rotation angles, which we can export out to whatever software and whatever rotation you would like, and see our model ellipse in our 3D viewer. So once you're happy with that, we also handle the back transform within Supervisor, so you don't have to do any gnarly maths for yourself. Simple as right-clicking and exporting it out into a CSV. Then you basically have your parameters set up, ready to go in the software program of your choice. So that is a crash course on variography in 5 minutes. So hopefully it's not all new to you, but yeah, it's a very useful tool, particularly for time saving. So another tip and trick for variography is, particularly in the multi-element space, is being able to actually copy and paste your rotation angles through your multi-element data without having to redefine this again and again in the same ore body. So you can basically hit update on those rotation angles and start working on your continuity models as the rest of the project updates. So one of the beauties of Supervisor is as it's updating other components, you're not locked out of anything else and you can continue working. So every minute helps when you're under pressure, so it's pretty cool. And then you can get on with actually modelling your structures pretty quickly. All right, so moving on to our creating neighbourhood analysis. So basically our creating neighbourhood analysis is all about optimising our parameters. So here, after we've finished modelling our variography, we right-click and add K&A. We're using the conditional bias statistics of creating efficiency and slope of regression to do this. I'm just putting in some generic block sizes here to test as the parent size. But basically, over to the right, you can sort by your creating efficiency or your slope of regression, depending on what you are preferentially choosing your block sizes on. And the maximum will basically populate on the right. You can also have a look at your negative weights as well. And you do have a full table of results from this as well that you are able to export. So again, you can have a look in the 3D window, the optimization tests using the middle of the block of the data set. But once you basically come back into this space, you can choose your block size, refine, and then move on to your sample analysis. So here you're obviously looking at a point of inflection and then where it plateaus as well. So we'll choose something like 12 to 28. If you do hover over any of the samples, it will show you all the statistics as well. So having a look at the search neighbourhood analysis, this is obviously pulled in from your modelled variography. I haven't changed anything here, so obviously the ratios are all the same, but it automatically tests for 2/3 of your variogram range, 90%, 100%, 150% and 200% as well. And then the final step is the discretization process. So again, once you choose that, that is our creating neighbourhood analysis tool in a nutshell. All right, so once we've run our estimation, we can then come back into Supervisor and do our model validation. So what we have to do here is ensure that our block models are being loaded in the same grouping order as our input data from our drill holes. Otherwise, they won't talk to each other during our model validation. So here we've loaded it by domain over assay to match our input data, and then we're going to right-click and use our model validation tool. Our source is our block model name, and the assay is the assay in question. So we'll just update that, and we can start seeing all of our trend plots populate, as well as the histogram, log probability plot, grade tonnage curves if you want to execute them as well, and our overall model statistical comparison table. So on a note here, the granularity will automatically be based on the smallest subcell size. Supervisor picks up on that, which is why sometimes you'll get really small values in there. So just something to be mindful of if you are wanting to slice at regular intervals. So we can update those to 5 meter granularities and have a look through and see our model validation. Yeah. So obviously as well, we've got our histogram to double check if we've got any biases over certain cutoff grades, log probability plot as well, and Q2 plots if you're interested in that. Obviously the summary table can also be exported out. You'll see you've got your raw sample data, your block data, and then the difference between the two in those statistics. So declustering is also an important tool to consider when validating your models. Obviously, with a lot of underground operations, we tend to get clustered data. There's a couple of ways of doing declustering in Supervisor. So again, you right-click on your input data and put the decluster on. If you automatically know the cell size you want to, you can input it there and hit apply. Otherwise, you can actually step through some cell sizes and optimize that window and have a bit more of a look at what cell size you do want to decluster to. So here at the moment, we are currently viewing our data with no links spatially. So you generally just click on a node when you're happy with it. If you do want to look at our spatial links, we do have the links and the planes in which they're connected, which which can also aid further to your understanding of where you want to place that decluster. You hit apply, and then basically you can see now the model validation tool will want to update. So we can update that and have a look at our slicing plane. The decluster becomes now available as well, so you can put that on your trend plots as well, so you can do further analysis into the validity of the model created and have a look at that spatially to see how your resource model is performing. So as well, when we have a look at our summary table, we now also have the declustered sample data, as well as the difference between our block model and our declustered data, and we can obviously export that all out into a table for reporting purposes. So the final tool I want to go through is the grade tonnage curve. A common request we get asked about is what's the best way to put two different models on a grade tonnage curve. And the best way to do a comparison between the old and new model in Supervisor is to do it through that model validation tool as well. So here we're going to load an older model to compare that with our new model in the grade tonnage curve. So again, we just have to be mindful that we're loading it by the same domains, grouping wise. And what we are going to do is add in the model validation again and have a look at our assay in question being gold. If you do want to change the colours, you can through that properties window at this point as well. So at the moment, I've got black and grey being populated. Obviously, you'll be able to see this in your swath plots now, so you can see spatially where those tonnes have been added or removed through that. To add your grade tonnage curve, we need to put a start and an end grade for our cutoff values. We can then go over to draw and click those components on, and we can now see we've got our old model in grey and our new model in black, and we can put on tonnages and the grade on the graphs, as well as we've got this great results table that is available to us as well, which of course is entirely exportable to a CSV. So that there is grade tonnage curves in a nutshell. So this has been a lot to go through today, but we do have some upcoming training if you are interested in learning more. Oscar Rondon is doing an advanced resource estimation course, which also covers our multivariate simulation component, and that'll be running from the 31st of May to June. We've also got a practical variography using Supervisor coming up mid-June, which is great for people who are being introduced to the concept and theory of variography, as well as learning how to do ordinary creek models. We've got just the Supervisor fundamental course in mid-June as well, and we do have some one-day courses solely on both the univariate and multivariate data at the end of June. We do online courses as well, so they're spread into 2 days over 3-hour sessions. But if you do have any training requirements, please do let us know.